Good afternoon. We are going to talk about the rate of change. Our group is made of our members Anthony Quito, Wimper Villafuerte, Jeremy Stanesaka, and I, Miguel Pico. The rate of change in mathematics is a measure of how one quantity changes with respect to another. It tells us how the dependent variable changes when the independent variable changes. This concept is fundamental in understanding real-world phenomena that involve change of time, like speed, growth, or the sleep of a line. For instance, when you drive a car, the rate at which your position changes with respect to time is known as speed. The faster you go, the higher the rate of change. It's a concept in calculus as it helps describe how functions behave as their input change.
Average rate of change. Now let's talk about the average rate of change. The average rate of change measures the total change in the function over the certain interval divided by the change in the independent variable. This goes as an overall measure of the function behaves between 2 points. We can visualize this as the slope of the straight line continuing 2 points and a graph. The formula of the average rate of change is function the A and function the B are the function values at points and A and B respectively, and A and B are the corresponding values of the independent variable. For example, if you want to calculate the average speed of a car over a certain distance, you will use the formula for the average rate of change divided to total distance by the total time.
Instantaneous rate of change. On the other hand, the instantaneous rate of change refers to the rate of change at a specific point. This is much more precise and is calculated using the derivative on the function. The derivative gives you the rate at which the function changes as the independent variable changes at that exact point. For instance, if you're driving a car and want to know how fast you're going at a particular moment, you will calculate the instantaneous rate of change. This is often represented as the slope of the tangent line to the curve at that point.
Examples and importance. To give some concrete examples, the speed of a moving car is the rate of change of its position with respect to the time. The slope of a straight line represents the rate of change of the vertical coordinate with respect to the horizontal one. Another example is population growth, where the rate of change is how the number of individuals in a population increases over time. The rate of change is not only important in mathematics, but also in fields like physics, economics, and biology. In physics, for example, we use the rate of change to describe the velocity, acceleration, and even force. In biology, it's used to model population growth and the spread of diseases. Thanks for your attention.
Yeah. Instantaneous rate of change. On the other hand, the derivative instantaneous rate of change. Bueno, the derivative. Oh, what's that?